Good day, students. Today we want to use an inclined plane to determine the coefficient of static friction. We use mu to represent static friction. We want to analyze this diagram, this inclined plane. This is an inclined plane. Inclined plane, where we use to push a heavy load with higher place. Now let's see what we want to analyze. Now this is based on what we have here. This is the limited friction. You can see it. This is a normal reaction. This is a limiting friction. We want to get static friction, mu, coefficient of static friction. Now what we do is that this is theta. This theta here is also equals to this theta. Whatever you have here will be equal to this. Now, this is opposite to this angle, and this adjacent. This line is adjacent. This is hypotenuse. Hypotenuse. Now, we want to derive an expression for this. Now, what we need to do is that say is SOHCAHTOA. When we are picking sine, we have sine theta, sine of this angle equals opposite over hypotenuse. What's the opposite here? It's F. Hypotenuse is W, the weight. When you cross multiply, we have F equal to sine W sine theta. That's equation 1. Now, to get the adjacent, this is the normal reaction. This R is the one that moves like this. Cos theta equals to adjacent over hypotenuse. What's our adjacent? That's R. This line, what that goes on. R over hypotenuse W. Cross multiply, R equals W cos theta. That's equation 2. Now what we need to do is divide equation 1 by equation 2. Now sine, we have F over R equals W sine theta over W cos theta. This W cancel W. F over R equals tan theta. And that is equals to mu. When you cross multiply, F over R equals to mu. Now F equals to mu R. That means that limited friction equals the coefficient of static friction times normal reaction, where F equals to limiting frictional force, mu equals coefficient of static friction, and R equals normal reaction. I'm going to use this to solve problem. Is 2 kilograms. Now, there's a force, you want to push it up, let's call it P. As you're pushing it, there's another force bringing it back down. At what's the angle? 60 degrees. Don't forget our mu is equals to tan theta. How do you get tan theta? When you have F over R equals sine theta over cos theta. Don't forget sine theta, cos theta is tan theta. F over R equals to tan theta. Sine theta over cos theta is tan theta is equals to mu. I'll show you how we arrive at that. Now we have this, the force is pulling it down. Normally, so this is the normal reaction that's coming up. The mass is 2 kg. This normal reaction R. The dotted line will show that normally it's supposed to go straight, but the force that we apply come down is this, which is weight. The weight equals mg. If this is 60 degree, this also be 60 degree. 60 degree, 60 degree. Now I want to know force is F that's pushing it. This is hypotenuse. This is adjacent to this angle. This is the opposite. Okay. Now we need to get the equivalent opposites to this angle, this line. That's why I have to use SOHCAHTOA. To get the force limiting friction toward the side, that's sine theta, sine all the theta 60 degree. Let's leave it as theta first. Sine theta equals opposites, which is F over hypotenuse, which is W. Now W, now F equals to W sine theta. That's our equation 1. Now to get the one that is vertical because of this normal reaction, that's adjacent to this, we use cos theta equals adjacent, which is R over hypotenuse W. R now equals to W cos theta, which is equation 2. Now, to come to this that I'm saying, you divide equation 1 by equation 2, it will be F over R, W cancel out, sine theta over cos theta will give you the tan theta, which is coefficients of static friction. Now we have gotten, you must get force that will, the tension that will pull it down. And the first one you get as F is this. And it has to go with frictional force. Now you now have tension to be mg, also this weight, so is W is mg sine theta plus the frictional force, limiting friction, which is mu r. It goes with it, limiting friction. This tension, what is here coming down, is parallel to this line. Whatever you get is the same thing with this, and you have gotten it from here. Equal to W sine theta. You replace your W with mg sine theta plus limiting frictional force. So this appear when the object is moving on a particular surface. Now you now have tension to be equal to mg sine theta plus mu. I told you that when you want to get what you have here, it's like when you have divide equation 1 by 2, F over R equals W sine theta over W cos theta. W cancel W. We have F over R equals tan theta, which is equal to limiting coefficient of static friction. Now from there, that means our mu is tan theta. can now say tan theta. What's our R? We put this one there. W is what? mg cos theta. Your attention now equals what's our mass? We have the mass. Our mass equals 2 kilogram. Our theta is 60 degree. And our G, center to gravity, is 10 meter per second squared. We have mass is 2 times 10 times sine 60. The angle is 60 degree plus tan 60 degree times 2 times 10 times cos 60 degree. You do your calculation very well, you get 3, 4, 0.64 Newton. Don't forget we have our diagram to be like this. 60 degree is the object, the mass, normal reaction is acting upward, dotted line, and the weight will act like this. This is mg, 60 degree, this is 60 degree. This is the parallel force, the force that will pull, as you are pulling up, that resisting force that's pulling down. This is not normal force. We want to use to pull it up in the inclined plane. Now, the force that is pulling it down, the tension, is what you got as 3.64. Now, the parallel force that will just move the block of the plane must be greater than this. But this is the tension will just move, that will pull it down. Tension pull it down. Force that will pull it up the plane must be greater than 84.64 Newton. This is the end of our class. Please subscribe to my channel so that you get the latest video. Have a nice day.